I'm going to go through the answers to these transformer questions for you, so if you can mark yours, that would be great. Number 1, figure 1 shows a traditional transformer. Okay, which metal should the core of the transformer be made from? So the transformer would be made from iron. Okay, and then it says, what would the reading be on the voltmeter in figure 1? And you've got 2, 10 and 50. What it actually doesn't tell you is the number of coils, so you can't figure this out. You've got to just think about it. So here we've got a 10 volt AC supply. We've got more coils on our secondary, so it's a step up transformer. That means there's going to be a greater voltage on our secondary. So our answer here has to be 50 volts because it's a step up transformer, okay? And if there's 10 on the primary, that's the only answer that is available for that's bigger than 10. So I'll just pull this down a bit. So the reason for our answer here would be there are more coils on the secondary. Okay, so the potential difference has increased. Okay, that's our answer there. So you get 1 for 50 and 1 for your answer. Then, number 2. Well, sorry, part B. It shows a tablet computer and its charger. Okay, and the charger contains a switch mode transformer. Now, we don't really need to know about switch mode transformers. We don't need to know what that is. But it says use the correct answer from the box to complete the sentence. So we don't need to, sorry, I'm reading this, but you don't actually need to do B at all. So you don't have to answer any of B, sorry. In fact, yours, it probably hasn't even got that question on, because I think I probably deleted it. Right, let's look at the next one. Figure 2 shows the structure of another traditional transformer. We've got 230 volts on our primary coil. And it says there is an alternating current in the primary coil of the transformer. State what is produced in the iron core, 2 marks. So for 1 mark, you want to use the word alternating or changing. And for the other mark, you need to say magnetic field. 2 marks, okay? Then it says the transformer has only 1 turn of wire on the secondary, and it gives you some different potential differences here. Calculate the number of turns on the primary. So let's set up our values. So our voltage on our primary is 230 volts. Our voltage on our secondary is 11.5, and the turns of wire on the secondary is 1, and we want to find NP. So then we put NP on top, divide it by the other N, and then on this side we put VP on top and divide it by the other V. We'll put our numbers in. Okay, and actually because you're dividing by 1 there, it makes this nice and simple. We get NP is equal to 20. And that's your answer. Okay? Then, in most transformers, the power output is less than the power input. Okay, that's true of any machine, really. So why is that? That's because energy is always wasted. So the transformer is not 100% efficient. And that's really the part that they're looking for in your answer. The is not 100% efficient section. Okay. Now, let's go on to the next question. D. And D says, two students investigated how magnets can be used to produce a potential difference. So now they're generating electricity. So the students held a coil of wire above the magnet and then lowered the coil. So they're moving a coil of wire near a magnet which generates electricity. Now they're not spinning it, so they're not going to create AC, they are just moving it down, so they're going to create DC. They looked at their results here, okay, and the first question says, give one reason, state the resolution of the voltmeter and give one reason why the resolution is suitable for this investigation. So the resolution is what it can measure to. So the voltmeter can measure to 0.01 volts, because that's how many decimal places there are. Okay? And the reason it's suitable for the investigation is because there's a change in the reading every time. If the resolution was much higher, you wouldn't always get that change. If the resolution was 0.1, our values here would be 0.1, 0.2, 0.3, 0.3 and 0.4, and so we're not getting a change there, but because our resolution is better than 0.1, it's 0.01, we can actually see there is a difference there, and that wouldn't be picked up. Okay, so the reason this is suitable for the investigation is there is a change in potential difference in every reading. Okay? And then the two students use exactly the same equipment to carry out their investigations, and both students recorded their results correctly. Give a reason why student 2 got different results from student 1. So what variable is there in here that's difficult to control? And actually, one of the things that affects the amount of potential difference induced is how quickly you move the coil. So we talked about we're spinning the coil faster. How did the students ensure they were moving this coil at the same speed? They probably couldn't. So that's the one that's giving them the different results. So they moved the coil with different speeds. Okay, 1 mark. Next question. The students decided that even though the results were different, there was no need to repeat the investigation. How do the results show that the investigation is repeatable? Okay, oh sorry, reproducible. But even though they got different results, they're actually following the same pattern. Look, as the number of turns increased, the potential difference induced increased. So because they follow the same pattern, that means they're reproducible. So they produce the same pattern. That means, so reproducible is about patterns. So they produce the same pattern of results. State the name of the process which causes the potential difference to be produced in this investigation. So what is this called? It's called electromagnetic induction. Okay. And a transformer has been developed that can be used with many different devices. So just one advantage of having a transformer that can be used with many different devices. There's loads of reasons for this. You could have it's more economical. Okay, it's cheaper to replace if it breaks. It's fewer transformers need to be made. Okay. Question 3. Transformers are used to change the potential differences in the national grid. Step-up transformer is used in the national grid. And the first question says, use the words from the box to label figure 1. So the words you should have here, this is the primary coil. Okay. This is the input potential difference. This is the iron core, and this is the secondary coil. So there are 4 marks available there, 1 for each. 4 marks, that's such a gift. Okay, 4 marks is a gift in an exam, just labelling this. Okay, let's have a go at the question, the maths question then. One of the coils has a potential one of the coils in figure 1 has a potential difference of 25,000 and the other coil has a potential difference of 40,000. Calculate the number of turns on this other coil. Well, we know it's a step-up transformer, so this one's going to be on the secondary. Okay, so we know, so let's do our V on our primary is 25,000 kilovolts, so 25 kilovolts, 25,000 volts, and we know its number of turns is 1,000. We know our voltage, potential difference on our secondary is 400,000 volts, but we want to find it's this. So we're going to put this on top. So we're going to say NS divided by the other N is equal to VS divided by the other V. So let's substitute our numbers in here. So NP is 1,000, VS is 400,000, and VP is 25,000. Now, if it was me, I'd just figure it out from here, but if you need a little bit more support in how to sort that out, you would then just do this side first. So 400,000 divided by 25,000. I better just do that because I'm not doing it. So 4 is 16. Okay, so then NS will be 16 and then you multiply by that 1,000 there. So my answer is 16,000 turns. Okay? Right, explain why a step-up transformer is used in the power station. We want to increase the potential difference. Okay? Which reduces the current. And the reason we want to do that is because the resistance is therefore reduced because there's less current. So there are less energy losses due to heat. Because it's basically the cables will heat up. The actual part they're looking for here is about basically there's less energy loss. That's what they're looking for in that last mark. But it doesn't harm to talk about this too, because you're saying, well, I know what resistance is too. Figure 2 shows a mobile phone charger. The charger contains a step-down transformer, and I think I've deleted this one as well because it's on about a switch mode transformer, so you don't need to do that one either. Question 4, we've looked at this question before. Scientists use a satellite system to investigate the idea of generating electricity in space. As the system orbited the Earth, a 20-kilometre wire copper wire was wheeled out. Before the wire snapped, a current of 1 amp was induced in the wire. What provides the force to keep the satellite in orbit around the Earth? That is gravity. And explain how current is induced in the wire. So we have the wire is moving through the magnetic field. Okay. So there is a potential difference induced across the ends of the wire. Okay, so and then we need to say the wire needs to be in a complete circuit. Okay, 3 marks for that. Then it says here, an alternator is connected to a data logger. So a data logger is just like it measures something and then turns it into an electrical signal in a computer. And it shows how the output potential of the alternator varies with time. So we can tell we're looking at AC here because you have a positive and a negative potential difference. Okay, and the question says that the coil inside the alternator now rotates at twice the frequency. Draw on figure 2 how the output potential difference varies with time. So there's 2 things you need to remember. It's going twice as fast, so the frequency is doubled, but because it's going twice as fast, it also produces twice as much potential difference. So you need to plot this really carefully. It's quite hard to do, right? But I would start with the crosses, so it's going twice as fast, so it's going to cross the middle instead of every 2, every 1. So we're going to cross the middle where these x's are. Then in between the x's, it's going to alternate between being up and down, up and down, up and down. And it's going to double the potential difference. So here, it's at, let's say 1, it's at 1.5 volts, I think. So when it doubles, it's going to go up to 3. So it's going to go up first, the same. So halfway through here, you're going to be at 3. And then underneath here, you're going to go to -3. So in between these two, it's going to go down to -3. Then up to +3, -3. Up to +3, -3, +3, -3. That's really hard to do. Okay, really hard. And then you've got to try and join up the lines. So you want to try and do a beautiful wave here. This is a really tough question at GCSE, okay? If you've managed to get any part of this right, that's great. Now the marks that are available are 4. So yeah, so that is worth a lot of marks, and the marks are for, there's 3 marks, no it's 2 actually, no 3, no 2, 2. So you get 1 for doing it twice as fast, no matter what the height is, and then your other mark is for getting the twice the amplitude, so at 3. Okay, so if you've got it at 3 but haven't done it twice as fast, you get 1 mark. If you've done it twice as fast but haven't got it at 3, you get 1 mark, and if you've done both, you get 2. And then it says another type of generator is now shown. Okay, and this type of generator shows this trace for potential difference. And you name this type of generator, so it's called a dynamo. So a dynamo produces this trace. So it's DC, it's direct current, so it's only positive, but it's not like a cell, which is just a flat line. Okay, so it's a dynamo. And it says give one difference between the outputs of the 2 types of generator. So the alternator, the potential difference changes polarity. Okay, dynamo does not change PD polarity. So you might get away with saying that an alternator goes positive and negative potential differences, but a dynamo only positive. So it's up to you which way round you go. Okay, and then F, little transformer question again here. So let's set up our values, and it says charges used to charge battery inside a laptop computer contains a small transformer. So it's a step down transformer. The charger plugs into the mains electricity. The mains electricity supply is 230 volts. So that's on our primary coil. The number of turns on the primary coil is 690. The number of turns on our secondary coil is 57. Calculate the potential difference on the secondary. So we'll set up our sum. So we put VS on top and divide by the other V. Then we put NS on the top and divide by our other N. Add our values in. VP, NS, NP. So VS over 230 equals 57 divided by 690, which is 0.08260 869565. Okay, and then we're going to multiply by 230. Okay, so VS equals 0.08260869565 times 230, which gives us an answer of 19. Now you don't have to do this bit here, you can just do it all in one go. If it was me and I was doing this, I would do it this way. I would just rearrange it straight away. So I would say VS is 230, so I'd move my 230 over times 57 over 690, and it saves me writing out this big number here, but it's up to you which way you prefer. Okay, add up your marks. Let me know what you've got so upload your marks onto the comment section in your in the classroom, please. Okay, thank you. See ya.